Hey everybody, this is Gregory from Dapp University. So welcome back to the multi-part series where I'm showing you how to create your own cryptocurrency and hold your own ICO on Ethereum. This is video number 3 in the series. In the last video, we started building our token contract, and in this video, we'll continue building out that token contract. So be sure to subscribe to the channel and turn on notifications with the bell below in order to see the next video in this series when it comes out. And if it's out already, you can check out that video at the end of this, or you can just watch the next video in the playlist. So first things first, if you haven't watched the other videos in this series so far, it's probably good to do that so that you can catch up and follow along. And if you want to download the code at this point in the tutorial, you can check out the link to GitHub in the description below. You can just download the project at this point in the tutorial and follow along. So before we jump into building out our contract more, let's just make sure that Ganache is still running. Okay, Ganache is good. We've got our blockchain running. So let's go to our token contract. So we left off, we set the total supply of all of the tokens in existence for our token here. So and we did that with the constructor whenever the contract was deployed for the first time. So I'm going to clear out those comments and let's see what we want to do next. So the first thing I want to do instead of hard coding this total supply is I actually want to accept a supply as an argument to this function. And again, this is the constructor for our smart contract. It's the function with the same name as the contract. And I can add an argument to this function, this constructor function like this. And this will be an unsigned integer, 256. And we'll call this the initial supply. All right. Now, when I accept this initial supply, I actually want to set it to the total supply here. I'll just say the initial supply, right? The total supply is going to be equal to the initial supply. We'll do more with this initial supply variable here in a moment. And you'll notice that I've used an underscore in front of initial supply. That's because there's a convention in Solidity that we use underscores at the beginning of variables that are only available inside this function. Again, this is a local variable, whereas this is a state variable that we've defined here. There's actually nothing magical about this underscore. It's just a convention. So if we are passing in the initial supply here, and this is the constructor function, how do we actually pass an argument into this whenever we want to interact with the smart contract as we're developing our project? Well, in order to do that, we need to visit our migration file that we created in the last section. So we'll do that. We'll go to our deploy contracts migration. And this deploy function accepts multiple arguments. At first, we can pass in the contract abstraction like we did for our initial deployment. But we can also add subsequent arguments, and those will be passed into the constructor function for our smart contract. And you'll notice whenever we did this the first time, we set the initial supply to 1 million. So I'll do the same right here. All right, 1 million. Now that we've done that, let's try to run our tests. Again, we wrote a test to make sure that our total supply is set to 1 million. Let's see if we broke anything. We'll do that with truffle tests. All right, they pass. Now, the next thing that we want to implement is a way to keep track of the balance for each account that might own some tokens. We want a way to, say, how many Dapp tokens do I have with my, specific address, or how many Dapp tokens do you have with your specific address? So we can see the documentation for that, for the ERC-20 standard. Again, we're, trying to make a token that complies with this standard so that it can be used on exchanges and things like that. And we can see that this standard gives us a function that's called balance of. And this returns the account balance of another account with address owner. So essentially, we want a function that is called balance of, that takes one argument. That's going to be the owner, or some sort of address. And this is going to be a reader function. This is why it's a constant. And it's going to return an unsigned integer that's going to be the balance. So it's a pretty simple function. Basically, it just takes in an address and returns a balance. Now, just like we did with total supply, I'm not going to write a complete function. I'm going to use we're going to declare a public variable that will give us a reader function for free, just like we did with total supply. But instead of defining, a simple unsigned integer data type, we're going to define a mapping. Now, a mapping in Solidity is like an associative array in other languages, or a hash table. And we can declare a mapping like this. We say mapping, and we give it basically a key and a value. Now, so a mapping is essentially a key value store, like an associative array in another language. And the key that we want to use for the mapping is an address. And the value is going to be an unsigned integer. And we're going to say this is public. And we'll call this balance of. All right, so let's just recap here. So this is a mapping. This is a new structure in our contract. This mapping is going to be called balance of, and it's going to be available publicly in our contract. And because we, declared this variable public, it's going to give us something like the ERC-20 standard requires. It's going to give us a reader function. It gives us a reader function here that is called balance of, and it's going to take in the address of the owner, and it's going to return an unsigned integer. So essentially, the argument for that function is going to be the key that gets looked up in this mapping, and the return value is going to just be this unsigned integer, which will be the balance of this particular address. Now, the first thing that we want to do with this balance of mapping is actually allocate this, total supply, or this initial supply of the token. So, this contract is responsible for knowing where each token is. We initially said, hey, we want to mint, 1 million Dapp tokens, but this contract is also supposed to know who has each Dapp token. And that's going to correspond to an address. So anytime a token is bought and sold or transferred, this mapping is going to be responsible for knowing where each of those tokens live. It's going to be responsible for knowing who has each token. And when we deploy our contract, we have to, give all the tokens to a particular address. They have to actually have a starting point. So we can do that here. We're going to allocate the initial supply. Again, we want to, say we're going to take these 1 million tokens and actually put them somewhere. And let's do this in a test-driven fashion. Let's actually write the test first, and we'll write the code to make it pass. In order to do that, I'm going to build on the test we wrote in the previous lesson. So I'm going to enter a new line here after our first assertion, and I'm going to say, return token instance, which we set here. This is going to be a balance of counts 0, and then we'll tap into this promise chain. Then function, we'll call this admin balance. This will be the administrator, and we'll assert that the admin balance is equal to this. We'll say it allocates the initial supply to the admin account. And let's go ahead and actually declare this variable here. And we'll clean this up too, just for consistency's sake. All right, so let's explain what's happening here. I'm running a test. Actually, let's do this. Let's put these side by side. So I'm running a test to say that whenever we initialize our contract, we want to take the initial supply that we accepted with this argument, and we want to allocate that entire supply to an administrator of this token. And since we have accounts available inside of our test suite here, we have all of the accounts available from Ganache. We can take the first account from this zero-based index array, and we can check the balance of that account to ensure that it has been set to this amount. And that's we haven't written the code for that yet. We're doing this in a test-driven fashion, but that's what we want to check for. We want to check that after we run this constructor, that the admin account has 1 million tokens that we're reading from this mapping. So we can run this test. It's going to fail. Hopefully there's no errors, but we expect just a failure at the moment. All right, so it's equal to 0, which is what we expect at the moment. This shouldn't have anything, and that also gives you a hint that this mapping is going to default to 0. It's actually an interesting characteristic. Mappings and Solidity have default values, and in the case of an unsigned integer, it's going to be 0. So let's make this code pass. What we can do is say that, let's actually do it above. We can say balance of, this is how we write to this mapping, balance of, we do MSG sender, and that's equal to the initial supply. Now let's explain what's happening here. We can write a value with this mapping by using brackets like this. This is pretty standard notation that you might have seen in another language. And we pass it the key, and we set the value. Now, this might look unfamiliar if you're new to Solidity. This is MSG is a keyword, or sorry, not a keyword. It's a global variable in Solidity that has several different values that you can read from it. In this case, sender is the address of the address that called this function. And in Solidity, there is metadata that can be passed to a function outside of its initial arguments. And the from value is always going to correspond to the sender. And in this case, when we run our migrations in development, it's going to be the first account in Ganache, because that's what Truffle is going to default to. So essentially, we're saying that we want, to write the balance of this account right here to be whatever we initialize our contract with. We want to take the initial supply and just set it all to this address. So again, we're writing to this mapping. This is the key. This is the value. And this is the balance of mapping that we declared here. And msg.sender is the account that deployed the contract. So we can run our spec to see if that works. All right, looks like there's an issue here. That's because I had a typo. My fault. Do that again. All right, it passed. Now, really quickly, I can show you some more resources to look at if you want to, kind of read about some of those things we just talked about, like msg.sender. You can go to solidity.readthedocs.io to see the documentation for the Solidity programming language. And here I'm on the page that talks about units and global variables. So here we can read about kind of the global variables that are available to us, and we can see msg.sender here. This is always corresponding to an address, and it says that this is the sender of the message or the current function call. And you can see everything that's available to you in Solidity. Like now, you can see information about the transaction. This is the gas price and the origin, the block, gas left, things like that. So feel free to examine this if you'd like. You can also kind of open the console really fast to maybe demonstrate a few things. We can use our Web3 object. Again, Web3 is just a library that allows us to interact with our smart contracts and the blockchain. I can show you the accounts that are listed in Truffle. You can see a list of those here. And I can show you the account. We can reference these by index. This will be the first account. This is the same thing as the accounts that come in our spec. All of the accounts that are going to get injected here are the ones that are available with our Web3 object, just like this. And also, I can give you an example of what is coming into our function whenever we call msg.sender. So I'm just going to do this with pseudocode. This won't actually be a function call in our contract because we haven't really gotten to this point yet, and we can look at that in a later video. But for example, if we had an instance of this contract, I could say, token.transfer. We're actually going to implement this function later. And I could say, let's transfer, let's actually look at the transfer documentation. We can say it takes, an address, and it takes a value. So we could say transfer to web3.eth.accounts 0. That's going to be the account that we want to transfer it from. Well, actually, let's go to 1, since we know this one doesn't have any tokens yet. So this is who we're going to transfer to. We're going to transfer from. Actually, let's look at the value. We want to transfer, let's just say 1 token. And this is how we get access to msg.sender in our function. So this is the metadata that I was talking about earlier. These are, the 2 arguments, the address 2 and the unsigned integer value. We expect this function to only take 2 arguments, but we take some additional function metadata. We can say from, and this is going to be the account, web3.eth.accounts, and we're going to say 0. And this is how we would specify, the account that this is getting sent from. And if we were to call this function and develop it locally, from metadata is going to be who msg.sender is in this function. Now, since this is a constructor, this is going to happen under the hood whenever our contract gets migrated. But I wanted to give you an example of that so that you're not just sitting there scratching your head. Now let's go ahead and add some more attributes to our token. We're going to give it some basic properties like a name and a symbol, and we can see what those things are available to us in our specification here. This is the ERC-20 standard. Let's give our token a name. We'll give it a symbol, and we'll give it. I'm also going to give it a standard. So again, we're going to use public variables for this. So we're going to get reader functions for free for our name and our symbol. So let's go back to our contract, and we want to add a name. Actually, let's do it up here. We want to add a name. We want to add a symbol. But we want to do this kind of in a test-driven fashion. So we can write the test for this. We'll add some new tests at the beginning. And let's actually update this one. It sets the total supply. We'll say it allocates initial supply. Okay. And we'll say, write a new spec that says it initializes the contract with the correct values. Gives a function. All right. So I'm going to give us one column here just to see this better. And what I'm going to do is kind of start off like we did here. We're going to return Dapp token .deployed, then function, and we're going to get an instance of our app, or our token here, sorry. And we'll say, token instance equals instance, and we want to return token instance name. All right, and we'll use our promise chain. Name, and we'll assert that the name, say name is equal to Dapp token. We'll say let's do it this way, and we'll say that this has the correct name. All right, so that's our first assertion. We can run that spec. Now let's get out of our console here. Let's do truffle tests. All right, it's failing. All right, we can say token instance.name is not a function. That's what we expect because we haven't written the getter for the name yet. So let's go do that. We can write a getter for our name like this. It's pretty easy. We'll just do the name first. We'll declare a public variable of string type, and we'll call it name, and we'll say it's Dapp token. All right. We can see this is the same name as our test. So let's run our spec and see if it passes. All right, it passes. So let's go ahead and add a symbol as well. We can add a new line here and say that we want to return the token instance symbol. Again, we do our promise chain. And we want to assert that the symbol is Dapp. All right. Let's run our spec. It's going to fail. All right, token.symbol is not a function, that's what we expect. So let's just copy this. String public symbol. We want to call this Dapp. So again, this symbol is essentially just, what, how our token is going to be referenced on like an exchange, or if you wanted to see it on a list. You guys are probably pretty familiar with that. This is just the name of the token. This is the symbol. So let's run this test now. See if it passes. All right, it passes. And let's do one more thing. Let's go ahead and add a standard. This is what I'm going to do. So then function standard. Let's return that here. Return token instance standard. Okay, and then we'll assert equal standard, and we'll say the standard is Dapp token version 1.0. We'll say it has the correct standard. Okay, run that. It's gonna fail. The standard is not a function. That's what we expect. I'm just going to copy this, add a new line. So string public standard. Call this Dapp token version 1.0. And let's see if that passes. There we go, it passes. So one thing to note here, standard is not part of the ERC-20 implementation. This is something that I've just used for my tokens that kind of gives you the version. So I'm just going to use that here. And name and symbol are both part of the ERC-20 standard, but they are optional. But they're pretty nice to have so that you can know your token name and your token symbol if it's going to get listed on something like an exchange.